Hi everyone, I'm Yanfang. Today I'm going to present our courses EMT265 Microcontroller and Interfaces mini project. For the theme that our group choose for this microcontroller mini project is automation system and is about sound detector for the baby application. So before we start our presentation, let me introduce our group member. The first member in our group is me, Tan Yanfang, and the second member in our group is Wan Ping, and the third member in our group is Chong Ka-yi, and the last member in our group is Ping Ji-jun. And all of us are come from RK85 Biomedical Electronic Engineering in UNIMED. So now I'm going to explain our group organization. In our group organization, actually we separated into 4 parts. For the first part is design source code for the program sound detector of the automation system for the baby application is done by 4 of us. And the second part is design schematic diagram of voltage regulator for PIC18 is done by Kai and Jijun. And the third part is design schematic diagram of sound detector module is done by me, Wan Ting and Kai. And the last part is design flowchart of the program is done by me and Wan Ting. So now I'm going to pass down for Jijun to start the introduction part.
Hi sir and my classmates, my name is Ping Ji-jun. I will start my presentation with introduction. Baby's cry is a common phenomenon and it is the most difficult problem which parents have to face when taking care of their babies. The cry of a baby is a biological signal to alarm about their needs. In order to motivate housekeeper parents to respond and indicates that babies need attention. Parents train their child for regular feeding, walking, and sleeping patterns following the strict routines most of the time without dealing with their physical and emotional needs. Researchers have found babies who cry and are being ignored all the time will not develop healthy social skills and intellectual. In addition, leaving a baby to cry could damage the brain development. So, in this mini project, a program is implemented to detect a baby's crying and turn on music. Next, I will discuss about brief description. Nowadays, parents do not get sufficient time to give attention and take care of their baby, as they are busy in their professional life. In addition, it is inconvenient to continually watch over or taking care of their newborn baby while doing their work or chores. So, in this mini project, we designed a simple program that implemented to detect a baby's cry in order to give out baby sleep music automatically. The system is based on PIC18F4580 microcontroller. Whenever the baby cries, it is detected by the controller with the help of mic and will turn on the buzzer, which acts like baby sleep music that creates calming sound as well as dim light LED, which makes babies sleep again smoothly. Besides that, it can detect babies cry while ignoring other sounds like clap, sneeze, fan, sudden sounds, environment sounds, and etc. That's all. Thank you.
Hi, my name is Chong Ka-yi, and I will be presenting on program functionality, advantages and disadvantages. In terms of program functionality, this program functions after it's stimulated by the sound detector module. This module interfaces the PIC18F4580 microcontroller by setting the input height, thus giving out soothing music and dim light as the output. Next is the advantages and disadvantages of this program. For the advantages, it is a simple program where all the components are easily obtainable. These programs help to calm down newborn babies while parents are busy with work. It stimulates automatically after it detects the baby cry. It contains potentiometer that acts as a threshold to control the sound level, thus preventing the unnecessary stimulations of the programs due to noise. Whereas the disadvantages of this program is that a malfunction of a component causes the programs to stop running. For example, if the mic in the sound detector module is short-circuited, the program will not operate because mic is the only input for the program. Next is the fixed time executions of the programs, which causes the programs to shut down earlier while the baby is still awake. For example, after the time execution of the program has ended, it automatically turns off while the baby is still awake. Thus, it causes inconvenience to the user such as parents. That's all from me. Thank you.
Hi, my name is Wing Wan Ting. My metric number is 1811511637. I will continue my presentation part. Now, I will discuss details about the system in this project. This project describes a sound detector automation system for the baby application based on the microphone sensor module and PIC 18 microcontroller. This system proposes a simple voice detection system which can be applied practically for designing a device which capability to detect a sound and automatically turn on a buzzer and LED. In this project, the PIC 18 microcontroller continually monitors the output from the MIC sensor module and turn buzzer and LED on when it goes active. MIC sensor is a sound detection sensor module that detects the sound of the surrounding environment. A PIC microcontroller to control the sound sensor module, which detects the sound of the surrounding environment and turn on off the output object or component. I will continue discuss about the flowchart for sound detector automation system for baby application. The MIC sensor is connected to port RB1, which is declared as an input. A buzzer is connected to port RC2, and an LED is connected to port RB3 with a current limiting resistor in a series. Both components are declared as an output. When the MIC motion is censored, the two components, which are buzzer and LED, will turn on. If the MIC motion disappears, the output will turn off. This process is repeated. I will end my presentation part. That's all. Thank you.
Hi, I'm Yen Fang. So now I'm going to continue to explain the schematic diagram and show the simulation part for our project. So in this figure, we can see that we choose PIC 18F4580, and for the upper part here, we design a voltage regulator for the PIC 18, and we consider 20 MHz crystal frequency and is connected to the bit RA6 and RA7 of the PIC 18. And after that, for the sound module part, we choose microphone as a sound detector and is connected to the bit RB1, and the buzzer is connected to the bit RC2, and the LED is connected to the bit RD3. And now I'm going to show a video of the simulation part of our project, and in that video, we can see that when there is a sound detect, all these 4 LED will light up. So now I'm going to continue to explain the source code part for our project. And this is the program code for our project. And in the program code, at first we can see that there are header file configuration. Then after that, in the main program part, we declare mic port DBRB1 as input, buzzer port CBRC2 as output, LED port bit RD3 as output also. And the program loop that we use are while loop because we want this program to keep repeating forever. And the conditional operator that we use are if else. So let's say if the mic is equal to 1 means that detect sound, the buzzer and the LED will light up and beep and will delay for 0.5 seconds. And if the mic is not detect sounds means that equal to 0, it will jump down at else and the buzzer and the LED are equal to 0, means that the buzzer and the LED will remain off and will not light up and beep. And this figure shows that our program code are built successfully in our project. So, in conclusion, a small size, low cost, and low power consumption sound detector automation system for the baby application was successfully designed, implemented, and tested. But in the future, there are several possible improvements that can be made in order to upgrade the feature and maybe using wireless technology to interface sensors, monitor relays, and microcontroller. So in brief, we've gone through a lot of new experiences and it's very beneficial for all of us in participating in this mini project. and sharpening our skill using software such as MPLAB IDE and Practice 8 Professional. And that's all from us. Thank you for your attention and hope you enjoyed our video.